Okay, so thank you so much and welcome to our another video. And in this video, we will be going to continue with the graph data structures topic, which is we will be going to deal with the Prim's algorithm, dealing with the maximum spanning tree. Then, since in the previous video we was able to identify the minimum spanning tree using Prim's algorithm. So we also do have here a for example, the same thing with their spanning with their frames algorithm and also maximum spanning tree. Now, let's actually move on, proceed. So our first example here is this kind of graph. And suppose that your first step is A and your goal is to maximize the spanning tree. Now, your A, you can check if what will be the maximum amount here since we need to maximize. So that will be A, yes, that is A to B, A to D, and A to C. So 10, 8, and 4. So you can actually go ahead and compare that one. What will be the maximum amount? So that is 10, which goes to B. So that will be our maximum amount number right now. After that one, what will be the maximum amount? You can check right here is that for A, the adjacent is 8, adjacent is 4, and for B, the adjacent is 7 and 1. Since 1 is loop, we cannot choose that one. So the next maximum amount is number 8. So we can choose 8. So that is your third step right now. So you have to step by step as always the same thing. For the next step, you can check letter B. That is 7 and that will be rejected because it will form a cycle and 1 will be removed as well. It will be rejected, will form a cycle. Is it 4 for A? Is it for D? Is it 23? So we can check compare. So 23 will be we can choose 23 since that is maximum amount. So since you have 4 vertices right now and you already attained 4 vertices, and if you will choose 4 it will form a cycle. If you will choose 7 it will form a cycle, and 1 form a cycle. So that means to say this is your Prim's algorithm right now for the maximum spanning tree. And you have to also total how much will be the maximum spanning tree for this graph. That is 23 plus 8 plus 10. That will become 41. So you have 4 vertices and you have 3 edges for that one. So that's how you will do that. And for the second example, let's try to proceed here. That will become the same problem here. So you just have to maximize this one. Suppose that your first step is A. Initialization step will be the A, your arbitrary vertex. And you have to compare, is it A to C, 12, A to D, 5. So you can choose 12 because that is the maximum amount. The third step, we'll be going to check for C, is it 22? Is it A to D? For 5, C to D, is it 4? C to F, is it 9? So that the maximum amount right there will be 22. So you can choose 22. That is for the third step. For the fourth step, you can check for A is A adjacent is 5, C adjacent is 4, 9, and for E adjacent is 15 and 34. No. We are still at E. So we can choose 15. So that is 15 right now. It's being added. Now, we can check here. A is 5 for A to D. C to D is 4. C to F is 9 and will form a cycle. That will be rejected. Then to D is 34. E to B is 23. So you can choose 34. So that's there in there already. So compare A to D, that is 5. That will form a cycle. So you have to reject 4. For C to D will form a cycle or reject. C to F will form a cycle, rejected. So F F to B, that is 23, and B to B is 13. So you can choose 23. So that is, you already do have all of the cycles here. I mean, vertices, I mean, since D to B cannot be chosen since it will form a cycle, and it will form a cycle. So rejected, rejected, and rejected. And that will be your final maximum spanning tree using the Prim's algorithm. And you have to make sure to sum it up. 34 plus 23 plus 15, 22, and 12. That will become 106. So you have 6 vertices and you have 5 edges. So that's how you will do the Prim's algorithm right there. So in the next video, we will be going to tackle all about the Kruskal's algorithm for this one. So see you there.